Evolution Mining is one of Australia's premier gold companies with a well-earned reputation for consistency and reliability. Established in 2011 and with 5 wholly owned gold mines as well as an economic interest in a 6th, Evolution's willingness to innovate and embrace new technologies allows us to develop our projects to their fullest potential as well as operate in a manner which is safe and efficient. Located on the traditional lands of the Woolly Woolly people, Evolution's Cracow Gold Mine is located 500 kilometres northwest of Brisbane and is an underground open stoping operation that commenced in 2004. Since then, Krakow has produced more than 1 million ounces of gold, with 90,000 ounces produced in the 2018 financial year alone. With consistent operational performance, the mine has a current life of until 2023, but maintains an exciting exploration potential. To understand the importance of this challenge, it's first necessary to comprehend the open stope mining process. This method involves mining one section of the ore body out at a time, and after each section is mined out, the empty void must be backfilled with waste material. This stabilises the area surrounding the void and allows us to blast and mine the next section. Because stopes are unsupported and unsafe for people to work in, removal of approximately 50% of ore is conducted using remote-controlled boggers. Due to the nature of this method, there is inevitable mixing of ore and backfilled waste, which is known as backfill dilution. Backfill dilution increases the cost of mining and reduces the opportunity to mine and process profitable material. It's difficult to separate the ore and backfill waste material underground, and Krakow does not presently own the equipment necessary to do so. In a nutshell, every tonne of backfill mined is a lost opportunity to mine a tonne of ore. The aim of the Krakow Mixed Tricks Challenge is to develop a method to minimise the amount of waste picked up while maximising the amount of ore extracted. To put the problem in perspective, there is an average of 300 tonnes of backfill dilution per stope, which equates to a total of 33,000 tonnes per annum across 110 stopes. Because each tonne of dilution costs $52 to load, haul and process, this means that per year there is a direct cost of $1.72 million to Evolution. But the potential loss in profits greatly increases when you factor in the lost opportunity to produce gold. If you replace the 33,000 tonnes of backfill dilution with ore, then that would produce almost 5,500 ounces of gold, which equates to a massive $4.23 million of potential profit lost. There are a number of controls that are presently in place. These include soaking the backfill with water, which makes the backfill stand up by increasing the angle of repose, utilising CRF or cemented rock fill to reduce dilution on wider stoping faces, and even simply leaving the lower grade ore in the stope once it becomes uneconomical to process. A few considerations for a solution include using CRF for all stopes, using a sure slot void filling bag, styrofoam or similar product prior to the use of CRF to create a void to fire in without the need to reslot, and the use of tensioned high strength chain link mesh placed over the edge of the stope to contain the fill once the next stope is blasted. These should not be considered the definitive solutions to this challenge. We encourage all participants to look for an alternative, creative and innovative solution to the problem beyond these considerations. It'll be necessary for the cost versus reward to be carefully considered to ensure that the desired outcome of a significant reduction in backfill dilution with minimal production cycle delays is achieved. We wish you good luck in this challenge and eagerly anticipate the solutions that you develop for this problem.